Hello, AP Stat students. So previously we talked about the various types of samplings, good and bad. We learned about convenience, voluntary sample, the simple random sample, and the stratified or systematic random sampling. Well, today I'm going to talk about a couple of more special types of random sampling. But before we do that, we'll review the simple random sample with an example problem. Suppose we wanted to estimate the yield of our cornfield. The field is square and divided into 16 equally sized plots. So we have 4 rows and 4 columns. A river runs along the eastern edge of the field. We want to take a sample of 4 plots. And so you should already have your calculator set to where you've made it random, the calculator random table. But if not, it's okay. Using a random number generator on our calculator. And here's what we would do for this particular problem. We would pick a simple random sample of 4 plots. We would place an X in the 4 plots that you would choose. Like if we were in class, you would each do this and I'd have you go about and figure out the means and stuff. But for our case, this is how I would do it. So we would use the rand int of our calculator, and our lower bound would be 1. Our upper bound would be 16, and we want a sample of 4. So this is our sample size. So lower bound, upper, and sample size. You have to label this information when you're talking about showing your work. Okay, and then I did it ahead of time, and this is what I got as my 4 numbers: 3, 6, 1, and 15. So 3, 6, 1, and 15. Right. And that is a basic simple random sample where each plot had an equal chance of being picked. These are for more random sampling, these are special types of random sampling which are used in case we are concerned that a specific subpopulation may be underrepresented in the sample. The first one is called a stratified random sample. In this particular sample, the population is classified into groups of similar individuals called strata. For instance, if we were stratifying by class, we would have the same number of freshmen, or we would have freshmen, sophomores, juniors, and seniors, and you would randomly pick 3 freshmen, 3 sophomores, 3 juniors, and 3 seniors by pulling names out of a hat. So that is an example of stratifying. So then a simple random sample is chosen from each strata. Combine the simple random samples for all your full sample. So here's an example of a stratified random sample, and I actually have these numbered incorrectly. What I should have done and what you can do is just the column should be all ones, and then the next one should be all twos, and then threes, and then fours. So this first particular one would be stratifying by rows. So basically what it is you have a homogeneous group. So each row would be homogeneous. Then you would select a random sample from each group. So we are going to use a random number generator to choose a box in each column. Oh, that's for the one for stratified by column, my bad. So for this one, we are going to do the same thing, but we are going to pick a box from each row. So in this case, we would do random integer, and we don't even have to put that 1 because we're going to do it 4 times. So what I got was I got a 2, a 4. In this row, I got a 3, and in this row, I got a 4. All right, so we'll leave that be. And then we would do the same thing over here. Have really nice boxes there. Not. Okay, and in this case, these would be 1s, 2, 3, 4. And here we are going to stratify by column. So this would still be rand int. And we are going to pick, I picked a number already. I did it randomly in for each column. And I got a 4, a 2, a 2, and a 3. Okay. And then you have the river over here. Okay. So basically, we're going to do more about this problem on the next page. But since the river along the right of the field will affect growth of corn, you want to sample each distance from the river. So stratified random sampling works best because it takes a sample from each soil type. And then we have a cluster sample. Now, a good example of a cluster sample using our grades again is dividing the population groups into smaller groups called clusters. These groups should be representative of the entire population. Students get the stratified random sample and the cluster sample mixed up, so I'll make sure to put additional notes online so you can have more examples. So not based on similarities to each other. Then a simple random sample of clusters will be taken. Survey every individual in the cluster. So for example, we could have 10 clusters, and in each cluster, there's going to be 3 random freshmen, 3 random sophomores, 3 random juniors, and 3 randomly selected seniors. And then you roll a dice and you pick one of those 10 groups. You randomly pick one of the 10 groups and you survey everybody in that group. So you get the whole cluster. So that's how a cluster sample works. So you basically start with a heterogeneous group, and then you randomly select a group, and then you use the whole group. So in our case, a heterogeneous group would be the freshman, sophomore, junior, senior, all in that one cluster. You randomly select one of those 10 clusters, and then you survey everyone in that cluster. So for this particular one, our clusters could be, this could be cluster 1, cluster 2, cluster 3, and cluster 4. And then you roll a die and you end up choosing, say, 4, but here's what I did. So I have 4 clusters. So I'm going to do rand int but you're only going to do it one time because you're going to get either cluster 1, 2, 3, or 4. And I ended up with cluster 4. So I would get all of these, right? And that is a cluster sample. All right, here's an extension. So comparing the mean amount of corn for each method, its harvest time and the amount of corn each plot yields is below. So for my simple random sample, the boxes I circled or crossed out or whatever ended up with these yields. And then for my stratified, the ones by the columns and rows, I'll show you what I have. I'll do different numbers. So rows I will do in blue. So I had 29, 153, 92, and 147. So these are my rows. And my columns were 31, 98, 5, and 148. So those are my yields for my columns, the numbers that I had circled. And then finally for our cluster, we had that fourth cluster. So we had these numbers. And so if the actual average yield, so the mean is 70, please compare the methods you use to the actual average yield. So what I did was I added these 4 yields together, divided by 4, and a simple random samples mean was 56.5. Did the same thing for the rows and columns. For the row, I got 421 divided by 4, which is 105.25. And for the column, I got 282 divided by 4, and I got 70.5. And then lastly, for the cluster, I got 281 divided by 4, and I got 70.25. So the best yield came from the stratified, and in particular the stratified by row. So, and as you can tell, you see why you ended up with yield closer to the river, and therefore you got a larger value. But stratified tends to work the best in this particular case. So what are the pros and cons of each random sampling method? The simple random sample is simple to perform. It's the one we use most often. There's still chance of over or under representation of a subgroup. And then when that does happen, that's when we pull in the other 2 that we talked about today. So stratified random sampling is more complicated to perform, but there's little to no chance of over or under representation. And then lastly, a cluster sample is convenient to perform. Oops. But underlying unknown patterns may cause over or under representation. So there are pros and cons of each random sampling method. And that kind of brings us to 4.1C. Why is our sampling method important? Well, the whole idea of choosing a good sample is for inference. So the purpose of a sample is to give us information about a larger population. So it's really important that we choose our sample very carefully because we want it to be representative of the entire population. So we can make a statement like, hey, all teenagers will have a car accident within 2 years of getting their license or something like that. So this is called inference, the process of inferring information from a sample to a larger population. This is basically the entire second semester when we do inferential statistics and we do statistical tests. It is unlikely that the results from a random sample are exactly like the results from the population. So why do we trust random sampling? Well, we trust it because since the error is due to chance and not bias, the laws of probability can be applied, and that's what we are going to learn in the next two chapters. We're going to learn about the probability rules. The laws of probability allow trustworthy inference about the population. Laws of probability also allow results from a random sample to have a margin of error, which sets bounds on the likely size of the error. And we will talk about margin of error second semester as well. One thing to remember though, larger random samples give better information about the population than smaller random samples. However, there still has to be a limitation because you can't have such a large random sample that because it's costly, it's harder to obtain that larger sample size. So there has to be some kind of in between. But you definitely there's limitations, but a larger random sample will give better information about that population than the smaller one. Okay, so what can go wrong with our sample surveys? Well, there's two types of things that can go wrong as far as errors go. The first one is called a sampling error. And the sampling errors, these are mistakes made in the process of taking a sample that could lead to inaccurate information about the population. So, one thing is bad sampling methods. And I mentioned that the voluntary response and the convenient samples are bad sampling methods. Voluntary, you have passionate people, or there you have people that are at the other extreme and don't give their opinions. Convenient samples are just easy to pick individuals. And the second one is undercoverage, um, when some groups of the population are left out of the process of choosing a sample. And it's not done deliberately, but things aren't thought through. And so that's why individuals are left out. So, for example, when sampling, this is dealing with the sampling households in the US using a simple random sample of phone numbers. Well, what about households without phones or people with unlisted numbers? Or how about people who are homeless or in prison or living in dorms, etc.? This is why it is really important to identify your population of interest. And this is not done deliberately, just not thought through, but it will affect your results. Okay, the other type of error is known as a non-sampling error. And this is an error that occurs after a sample has already been chosen. Okay. The first type is non response, and this is when an individual in the sample does not participate in the study. So, a perfect example is something that happens to me, and of course, it always happens during dinner time. So, I get a phone call and I decide to answer it. And would you like to participate in a brief survey about click? That's what I do. So, this is an example of non response. And the problem with this is if you have a high non-response rate, that's going to lead to inaccurate data because people like me who hang up, which I know is rude, but when it's during dinner, you got to have some boundaries. Um, we might have share similar characteristics with other people who are doing the same thing, and that could totally skew results. So increased non-response can cause inaccurate data. The other kind is response bias. This is when an individual gives an untrue answer because they feel their true response may reflect badly upon them. So, right now, obviously, a really big thing is the Black Lives Matter movement. And so, if you approach someone and ask them one way or another how they feel, they might um, say something that they truly don't feel about it. Like, they might give you that untrue answer because they don't want what they say to reflect badly upon them. So that is a response bias. And with a lot of survey questions that teens tend to do if they're given a project with peers, peers are always are tend to be afraid of what they might say based on who is even asking them the question. So think about those. Those can result in inaccurate data as well. And then lastly, the wording of questions. Confusing or leading questions may also lead to an inaccurate response. Don't trust the results of a sample survey until you have read the exact questions asked. So, here are some examples of bad wording and how better wording could result in better information. So, do you believe that cell phones in the classroom interfere with student learning and should be banned in the schools? So, this is definitely a leading question. Just the way it's worded, do you believe? Like, basically, it's saying that cell phones are interfering with student learning. We've put in all this money into education, and um, students need to be focusing. They should not be allowed to have cell phones in school. They should be banned. So that's basically leading someone to think a certain way. The second one, do you believe that cell phones can provide emergency access to students and should be allowed in schools? So here, this is also a leading question because it's basically saying or kind of insinuating that, oh, what if there's a active shooter and I need to call my parents, or there's a natural disaster and I need to get a hold of family to make sure everyone's all right and who's going to pick me up. So there's that pro against having the cell phone. So, but it's a leading question, just throwing in the words emergency access. Both of those questions are leading questions and can be questions under the guise of should cell phones be allowed in schools? This is a good neutral question. Okay. And that is it for our notes for today. Have a great day, stat students.